Assalamu alaikum dear students, and today we are going to discuss a solution of a system of linear inequations in two variables. You know how to solve linear equations, that is system of linear equations in two variables. Like if we have this system a1x plus b1y equals to c1 and a2x plus b2y equals to c2. Now this is the system of linear equations. Now you know that this linear equation represents a straight line, and this too also represents a straight line. Now the solution for this system actually is the points which are common to both the lines. Now here we have three types of solutions for this system. One, the unique solution, means when these two lines intersect at one point, that is, they have only one point common. Now when there is no point of intersection between these two lines, means this system has no solution, means consistent lines. And when line first this overlaps or coincides with line L2, then they have infinitely many points which are common to L1 and L2. Hence the solution is hence this system has infinitely many solutions. Now here we are discussing linear inequalities, and you know that solution or simply the linear inequality actually represents the portion of the plane. Now if we have two linear inequations in two variables, that simply means the system of linear inequations. Now the solution means, like in linear equations, we consider or we take the common points between the two lines which are represented by the equations. Similarly here in linear inequations also we consider the portion which is common to both the regions represented by the two or the individual line, this linear inequations. Now let me consider here an example: x greater or equals to 3, y greater or equals to 2. Clearly it is linear inequation, but in two variables, because if we consider this as a system, then it represents the linear inequation in two variables. So firstly we will draw the graph of this x greater or equals to 3. Now in order to draw the graph of this x greater or equals to 3, we firstly draw x equals to 3. Now x equals to 3 means this y-axis, this axis which is perpendicular to x-axis and passing through x equals to 3. Now we have here x greater or equals to 3, means actually it represents this x greater or equals to 3 means all the points which are greater than 3. All the points greater than 3 lies on this side or on this line, this. So this whole portion is represented, and the points on this line is represented by x greater or equals to 3. Similarly y greater or equals to 2 means we draw this y equals to 2, that is this line, and y greater or equals to 2 means this portion. So this is the equation and the points on this line. This is the graph or the solution portion of y greater or equals to 2, or the pointers from this region satisfies this inequation. Now here we have two regions. This region which is represented by x greater or equals to 3, and this region which is represented by y greater or equals to 2. Now we have to consider the solution, because linear inequation represents this region, and linear inequations or the system of linear inequations also represents the system, this portion or the part of the plane which satisfies or which is the solution region for all the region this inequalities. Now here the common portion, like in system of linear equation, in this case we find the single common point or the intersection of the points between these two lines. Similarly in this situation we consider the intersection of the solution regions of the individual linear inequalities, and that is this portion. So this portion is the solution region, or this is the region represented by x greater or equals to 3 and y greater or equals to 2. So in this case the solution region is this r, which is denoted this region which is denoted by r. So that is this portion. Now example second, we have to solve this 3x plus 2y is less or equals to 12, x greater or equals to 1, y greater or equals to 2. So here we have three linear inequations in two variables, because here it is simply this x greater or equals to 1, this is linear equation in one inequation in one variable. But if we consider this as a part of this system, these three equations, then then this is also linear inequation in two variables, because we may consider here x plus 0 y is greater or equals to 1. So we will draw here the graphs of each and every linear inequation. Here 3x plus 2y is less or equals to 12. Firstly we will draw this 3x plus 2y equals to 12, that is this portion. So this is the line which is represented by 3x plus 2y less or equals to 12. Now clearly the solution region, or the region represented by 3x plus 2y less or equals to 12, means the point is on this line and point is from this portion of this plane. So this is the solution region which is represented by R1, R1, or the region shaded by these dots, this portion. Now x greater or equals to 1, x greater or equals to 1 means we draw x equals to 1, that is we draw this vertical line passing through 1, and x greater or equals to 1 means the point is on this as well as the pointers which are greater than 1. So this means that is this portion. So this is the required portion which is represented by x greater or equals to 1, that is the area which is shaded by this, or the region which is shaded by these circles or circular dots. Now we have to draw this y greater or equals to 2. Now y greater or equals to 2 means the point is on y equals to 2 and above y equals to 2, that is this region which is denoted by R2, which is denoted by R2. Now here we have three regions, this region which is represents, or which represents y greater or equals to 2, this region, this region, this portion which is represented by x greater or equals to 1, and this portion which represents, or which represents 3x plus 2y less or equals to 12. Now clearly from the graph, the point of intersection, or the portion of the intersection between these three regions is this triangle, is this triangle. So clearly if we mark the end points a b c, then clearly the region represented by this linear inequations, or the system of linear inequations, is a b c a, because it is closed, because this a b c a is the region which includes both the regions, or which is the common portion between these three regions, between the region y 3x plus 2y less or equals to 12, x greater or equals to 1, and y greater or equals to 2. So this is the required solution region for 3x plus 2y less or equals to 12, x greater or equals to 1, y greater or equals to 2. Now question third is, we have to solve this system x plus y less or equals to 9, y greater than x, x greater or equals to this 0. Now x is greater or equals to 0 means this portion, because everywhere in this portion x is positive, means x is greater than 0. Now we will draw these two inequalities, x plus y less or equals to 9. Now we have to draw x plus y equals to 9, which is this line. This is x plus y equals to 9. Now we have here x plus y less or equals to 9. So this means that this region is represented by this, or the solution region for x plus y less or equals to 9 is this region. Okay, now we have y greater than x. Y greater than x means x minus y less than 0, because this is linear inequality. In order to solve y greater than x, we should solve this x minus y less than 0, x minus y less than 0, and x minus y less than 0 means x minus y equals to 0 is this line. Now x minus y is less than 0 means this portion. This is the portion which is represented by, or which is the solution portion or the solution region for x minus y less than 0. So we have here three portions. First one, this portion. Second, now this portion. Now third, this portion. Clearly the intersection between these three regions is simply this triangle ABC, or the region ABCA. So ABCA is, the solution region or the solution for this system of linear inequations. So this is the required solution region. Now how to solve the double inequality? Double inequality means where we have or an expression containing two inequalities, like 2 less or equals to 3x minus 4 less or equals to 5. Now here we have to find the values of x which satisfies this, or we have to find the portion from which x from which we can put the values. Like here we need 3x minus 4, so we have to cancel this 4. This means that we have to add this adding 4 on each and every side of this inequality. That is 2 plus 4 less or equals to 3x minus 4 plus 4 less or equals to 5 plus 4, or which is simply 6x less or equals to 3x less or equals to 9. By dividing 3 on both sides, it is 6 by 3 less or equals to 3x by 3 less or equals to 9 upon 3, which is simply, after simplification or division, 2 less or equals to x less or equals to 3. So 2, when x belongs to 2 closed interval 2 3, then clearly this interval 2 3 is the solution interval, or the solution region for 2 less or equals to 3x minus 4 less or equals to 5. So thank you.